Okay, so I'm going to kick off with an overview of what is the platform engineering technology stack and how does it fit with the other things that you're already familiar with from the world of DevOps and site reliability engineering. So yeah, I'm going to talk about those things. So the first thing is, what is platform engineering? So when we talk about platforms, it's not the platform business model that you may have heard of in like these multi-sided marketplaces like Grab or Uber or the e-commerce marketplaces. No, this is platforms as technology platforms. And platform engineering is about helping developers build new applications, but build them in a applying the best practices from industry and also their own organization and the rules and policies and standards of that. So what do platform engineers do? So the role of a platform engineer is to make sure that the platform is available for developers to create new applications to extend the platform. And as I said, to do it in a sustainable way by making sure that it fits with the tool chain associated with the DevOps pipeline, the CI/CD pipeline, and the other tooling. So platform engineering, a new term. DevOps, you're already familiar with. Site reliability engineering, you may have explored. So what I wanted to just characterize is where all these things fit. So DevOps, the main goal of DevOps was to really address this problem that was occurring when developers would write a bunch of code and then they'd hand it over to the ops team to run it. And sometimes it didn't work. And if it didn't work, the ops team didn't know enough about it in order to fix it, and they'd have to send it back to the dev team. And you end up with this never-ending cycle of bad code getting deployed and then being sent back to the developers to fix and not working very well. So the DevOps is really as a practice, really designed to help go through these development life cycles, the development cycles as quickly as possible, and because the learning will accumulate. If you spend 6 months before you release something, then the chances are by the time you release it, it's out of date or doesn't fit the user's need anymore. Site reliability engineering is also aimed at improving the reliability of applications, but it does it from the operations standpoint. And its role is to make sure that the platform is available, that it performs well, that is, you get good fast response times, that you don't get failures or you address any failures that occur. Platform engineering is not an either or issue with either DevOps or with site reliability engineering. It's really there to help developers to write good code by giving them frameworks, templates, and automation that helps them to create a new application and deploy it in a way that it can be supported well by the site reliability engineers. Now, in an organization, you may have different people with different sorts of terms, and you've got, sorry, I'll just go back one moment. So people may be called a platform engineer or a site reliability engineer, a network engineer. What are the other types of engineers? There's infrastructure engineer, lots of different terms, and different organizations will have different ways of dividing up the activities for each of these. Okay, so for developers in the DevOps environment, well, there are the key trends for developers are that developers should be tied into the whole lifecycle management of the application, not just build something and then rely on the testers to take over and then rely on the operations team to pick that up. So should be continuous. The CI/CD cycle should run as frequently as possible, not once every 6 months. You've probably heard the term shift left, and the testers will tell you they want to shift left because they want to be more involved at the start of an application's life. The security team want to be more involved at the start of the development lifecycle. So you're starting to see tools to help developers do that. And companies like Sneak and Mend provide tools that look for vulnerabilities as developers are writing the code and try to highlight this is not a good practice, you should do something about that, and actually scan the source code as it's being written. Embedding best practice. So organizations not only want to apply industry best practice, but they have their own practices. They may have their own styles. They may produce a style guide for coding that they want to make sure will achieve some consistency across every application, regardless of which developer created it. And if you've looked at some code that was written by different people, you can see often people introduce their own sort of style, but that makes it hard to manage large applications. And the documentation shouldn't be an afterthought. It should be applied all throughout the development lifecycle. And simply producing a PDF or a Word document afterwards is not great. It should be controlled also. The way you control source code with a version control system like GitHub or GitLab or Bitbucket, so it should apply the same sort of activity to documentation, because if documentation goes out of date, then nobody can support the application. When it comes to site reliability engineering, there are a whole lot more tools, because the site reliability engineers are looking at not only communicating among their team, they're also deploying applications to different environments, often different cloud providers, and the provisioning of new systems, the scaling up of systems through things like Kubernetes is a pretty involved job. So there are more tools in the SRE's toolkit. Automation to different cloud providers, to different activities, so that you don't have to do so much of the command line activity, is also becoming more important, and is becoming more important for people to be able to use those tools to automate things. And then, of course, there's the monitoring to make sure that we can keep up a system not only goes up, but it stays up. And we know exactly what's happening if there is a problem. Okay. So the platform engineering tools, as I said, they really revolve around giving the application developers, firstly, the knowledge of the technology stack, and also the tools to create a new application. If you're creating, say, a Node application that's going to expose APIs, then you probably want to use the Express module. If it's going to authenticate users, then it needs to link in with the organization's authentication system. And then it should also have the appropriate modules to monitor the system, so that the site reliability engineers can support it. So a good internal developer portal provides not just a way to gather good documentation together from across the organization's data sources, but also provides templates or scaffolders for producing new applications. So there are lots of benefits to having an internal developer portal, and this is probably where platform engineers really want to reach in order to make sure that their organization can sustain their operations, and has benefits across across the organization. As with DevOps and site reliability engineering, to be successful at this, you really need to be a learning organization, constantly looking at how to improve things. And some of the practices of site reliability engineering, like conducting post-mortems on incidents and things like that, are really part of that, building that learning culture. So without being a learning organization, no amount of tools will be able to fix your problem. It's probably the right place to start is actually to think about how you build a culture of learning within your organization. Okay, now there are other sources to learn more. Google has produced some good material on site reliability engineering, and platform engineering is a little bit newer, but there's a good site here, platformengineering.org, which has a lot of valuable information about a growing field. Okay, so I think that's me. So I'm going to pause now, and I'm going to hand over to Yong Kang. Thanks very much.